Hi there. In today's lesson, we're going to be introducing decimals and we're going to be looking at addition and subtraction of decimals. So let's just quickly start with what is a decimal. Let's get a definition down in our books to start with. A decimal. Well, it's a way of writing a number that is not a whole number. If you like, it's a number that is an in-between number. So for example, 2.5 or 2.5 as a decimal is in between 2 and 3. So let's get that written down as a key point in our books. A decimal is a way of writing a number that is not whole. It is a number that is in between two whole numbers. I'll say that again. It's a number that is in between two whole numbers. Apologies. In between two whole numbers. Okay. For example, 10.5 is in between 10 and 11. Okay. First key point of the day. I am going to use my highlighter pen just to make that all clear in my book. A decimal is a way of writing a number that is not whole. It is a number that is in between two whole numbers. And there's your example. For example, 10.5 is in between 10 and 11. Okay, so we use a decimal point. Let's get that written down as well. A decimal point separates the whole Okay, let's read that. A decimal point separates the whole number part from the part less than 1. Let's do another example. For example, let's look at the number 123.456. Okay, 123 is the whole number part. We've got our decimal point in between. And then we've got 456, which is the part that is less than 1. Okay, the whole number part 123, the decimal point, and the part less than 1. All fairly straightforward. So let's move on. Let's quickly look at place value. Okay, so let's look at a number. Let's use the same number, why not? 123, yep, 0.456. Let me draw this out before you copy it down so you can see what I'm doing. So I want to label the columns for my number. So I've got hundreds, I've got tens, I've got ones, I've got tenths, I've got hundredths, and I've got thousandths. Okay, I've got tenths, which I can also write as 1/10. I've got hundredths I can write as 1 over 100, and thousandths that I can write as 1 over 1000. Let's just neaten that up a little bit. So let's make sure that goes through there. Okay. All right, so we've got hundreds, tens and ones, tenths, hundredths and 1000ths. Right, I just want to mention expanded form here. Again, let's stick with the same number, 123.456. Just as a matter of interest, when we say this number, we say 123.456. We do not say 123.456. So we say all of these numbers individually. So in expanded form, I've got 1 in the hundreds columns, as we know from our place value table. So I've got 100. I've got 2 in my tens column, so I've got 20. I've got 3 in my ones column, so that's just plus 3. I've then got 4 in my tenths column, so I'm adding 4 tenths. I've got 5 in my hundredths column, so I'm adding 5 hundredths. Finally, I have the number 6 in my thousandths column, so I'm adding 6 thousandths. That's how we write it in expanded form. And then just looking at the value of the digits, Right, let's use a different number now, just mix it up a little bit, make sure you can still see what we're doing. Okay, so let's just use the number 7.352, doesn't matter, make up any number that we want. If I asked you, for example, what the value of the 5 was, the value of the 5 is 5 in the hundredths column. The number 5, which is in the hundredths column, so we have 5 hundredths. Similarly, if I asked you for the value of the 2, it would be 2, but in the thousandths column. Hopefully you can see that just squashed on the bottom there. All right, let's move on to comparing decimals and ordering them. So let's put a new little subheading up here of ordering decimals. Okay, now if you're asked to order decimals, you'll be asked to order them from smallest to largest, or you might be asked to order them in ascending or descending order. So let's just put a little note there so that we know what those terms mean. So ascending means smallest to largest, and descending means largest to smallest. So imagine if you were going on a walk up a mountain, ascending would mean going up the mountain, and descending would mean coming back down the mountain at the end. So I'm just going to put that in one of my little learning bubbles, just as a little reminder in case we've forgotten. Okay, so I'm going to order these decimals in ascending order. Okay, so I'm just going to write in ascending order, and the 4 numbers I've chosen, I've got 0.417, I've got negative 0.4, I've got 1.1, and I've got a negative 1.5. Now, my suggestion for a question like this is to draw yourself a quick number line. It doesn't have to be particularly accurate or to scale, but you just want something so you can visualize what we're looking at. So as I say, it's just a quick sketch. I mean, I'm going to try and make it reasonably accurate, but as I say, it is just representative. Here's my number line then. And if I put my numbers on the number line, it's going to help me establish what the correct order is. So let's see, I've got 0.417 here. That's just a little bit less than a half. So I'm going to put that there. I've got a negative 0.4. So that's going to go approximately there. I've got a 1.1. 1.1 can go there. And then finally, negative 1.5. So that is going to be down here, negative 1.5. Now, the advantage of using a number line is twofold. Firstly, it helps you see that this number, just because it's got more digits in it, isn't larger than this number. Remember, when we're comparing decimals, we always want to work from left to right and look at the column furthest to the left first, because that's the largest part of the number. So the 0 here is clearly less than the 1 here. The other advantage of using a number line is it really helps us with negative numbers. We know that the further away we are from 0 to the left, the smaller the number. The further away from 0 we are to the right, the greater the number. So that helps us see that negative 1.5 is smaller than negative 0.4. So now it's fairly straightforward to put them in order. I've got negative 1.5, negative 0.4, positive 0.417, and finally positive 1.1. Okay, I don't have to use a number line. There is another way of doing it. I could just write them out using a place value table. I'll use a different example for this. So let's just call that number 1. Let's do a different example here. Say I was given, okay, so I'm going to compare 12.345 and 12.36. Now, using a place value table and lining them up really neatly, making sure that my decimal points are in line. Here's my 12.345. I've got 12.36. And then again, we work from left to right, and we keep going until we see that in the 100ths column, 4 is less than 6. So that allows me to see that 12.345 is smaller than 12.36. So I can now write that as 12.345 is less than 12.36. And indeed, I could write it the other way around. I could say that 12.36 is greater than 12.345. So just another quick reminder here to remember that the less than sign looks like this, the greater than sign looks like that. And you might have learnt it as crocodiles, and they always eat the bigger number. Right, let's keep moving on. Let's have a quick look at rounding. Okay. All right, we're going to round. At this stage, we're just going to round to the nearest integer. We're going to round to the nearest integer. If we need a little bit of a reminder, integer means whole number. Okay, integer means whole number. And remember that it could be a positive number like 3. It could be a negative number, maybe -2. It can also be 0. Okay, so just a key point there. Integer means a whole number. So we're going to round to the nearest whole number. And you might have come across a little saying. There's loads of different ways of remembering them. This is the one that my daughter was taught when she was at primary school. 5 or more, add 1 more. 4 or less, leave 2 rest. Okay, so let's do a couple of quick examples here. We're going to round to the nearest whole number, 73.4. Because we're rounding to the nearest whole number, we only need to look at what is in the tenths column. If there were numbers here, I could just ignore them. So 4 or less, leave to rest. That is going to round to 73. Next example. If I had 73.6, 5 or more, add 1 more. That's going to round up to 74. Now, if I had 73.5, which is exactly halfway between 73 and 74, we need to use our convention. And our convention states that for 5, we round up. So we round to 74. Finally, let's just look at one last one, 73.45. Now, we said that we only need to look at what's happening in the tenths column, which is a 4. Therefore, I know that this is going to round down to 73. The reason I've included this one is sometimes people use that 5 to round the 4 to a 5. And then they say, well, 73.5 rounds to 74. Okay, you don't want to do that. You only look at what's happening in the tenths column, and that tells you that you do not need to round the 73 up to 74. Now, the other thing that you can do is you can use a number line. Again, it doesn't need to be drawn to scale. It doesn't have to start at 0. My number line is going to start at 73 and go to 74, and approximately in the middle, which I'm guessing is about here, I'm going to put 73.5. Now, visually, that's a really helpful way of seeing that 73.4 is here. So it's going to go down to 73. 73.6 is somewhere here. It's going to go up to 74. We're told that 73.5, the convention is to round to 74. And then again, you can't really see it, but if I squashed in here a little 73.45, you would see that it's still less than 73.5 and therefore rounds down to 73. So always remember that a number line is there to help you. It takes 2 seconds to sketch it out if you're struggling with working out which way it goes. We're now going to have a quick look at addition and subtraction of decimals. So we're going to put a new subheading up. Okay, now luckily this is fairly straightforward. We use the column method exactly the same as if we were doing whole number or integer addition and subtraction. Okay, so we're going to use the column method, and the only thing really that we need to remember with this is to line up your decimal points. So remember to line up the decimal points. That is the most important thing to remember. when adding and subtracting decimals. So let's do a couple of examples now. We're going to start with 1.357 and we're going to add 3.7. We're going to write it again as the column method. 1.357 and we're adding 3.7. You can see that your decimal points are hopefully perfectly lined up. But also look that we've got this number is to 3 decimal places and this one is only to 1 decimal place. So I'm going to put in some zeros here called placeholders just to make sure that we don't accidentally add up the wrong columns. So now we know that 7 plus 0 is 7, 5 plus 0 is 5, 3 plus 7 is 10, carry the 1, 1 plus 3 plus 1 gives me 5. So we've got 5.057 for our first answer. Let's look at another one. This time we've got a subtraction calculation. We've got 6 and we're going to subtract 3.186. Again, we're going to write it out using the column method and we're going to put in a load of placeholders because we know that we're subtracting a number that is to 3 decimal places. All right, so we're lining up as we go. Right, so it's a little bit trickier here because we've got to borrow from the 6 and then carry it all the way across. So that gives me 10 here, which I'm going to reduce to 9 to have 10 here. I'm going to reduce to 9 and I've got 10 here. 10 subtract 6 gives me 4. 9 subtract 8 is 1. 9 subtract 1 is 8. Carry my decimal point down, making sure it's perfectly lined up again. 5 subtract 3 gives me 2. Now this is where you guys get to check your own answer. So you don't need a teacher checking it for you. You can check using addition. Okay, so if I add back together 3.186 plus 2.814, then hopefully I'm going to get the number that I started with. Let's just double check. 6 plus 4 is 10. 9 plus 1 plus 1 is 10. 8 plus 1 plus 1. 1 plus 8 plus 1 is also 10. Carry my decimal point down. 3 plus 2 plus 1 gives me 6. You don't need me because you can see that you've got the correct answer. I'm not sure why that says 1 and that says 6, so we'll just ignore that. It's obviously been a long day. Let's change that to 2. Right. Okay, just a couple more. Question 3. I've got 0.73. We're adding 9.82 and we're subtracting 3.76. Remember, with our order of operations, addition and subtraction are of equal importance, so we work from left to right. So we're going to do the addition bit first. 0.73 plus 9.82. Same thing, column method, nice and straightforward. 5, 5, carry the 1, 10. I've now got 10.55 and I'm now going to subtract my 3.76. Let's have a look and see what happens here. I need to borrow from the 5. So 15 subtract 6 is 9. I now need to borrow from the 10. 14 subtract 7 is 7. And 9 subtract 3 is 6. So my answer is 6.79 again. You can check using addition if you wish. Finally, question 4. I've got 21.63, subtract 4.33, add 6.12. It's very similar to question 3, but the reason I've kept it in is that often with a question like this, particularly if people have been taught BIDMAS, they will do the addition calculation before the subtraction calculation. That is not correct. You're going to get the wrong answer if you do that. So we need to remember addition and subtraction are of equal importance. So we work from left to right. So this is your order of operations. Remember, addition and subtraction are of equal importance. So we work from left to right. I didn't even use a ruler then, did I? I'll be telling myself off later. Right, okay, so we're going to do the subtraction first. So we've got 21.63. I'm subtracting 4.33. Let's work that out. 3 subtract 3 is 0. 6 subtract 3 is 3. Okay, I'm going to borrow from there. 11 subtract 4 is 7. I've got 17.30. I'm now going to take my 17.30. I'm going to add my 6.12. Nearly there. 0 plus 2 is 2. 3 plus 1 is 4. Carry my decimal point down nice and neatly. 7 plus 6 is 13. Carry the 1. 1 plus 1 is 2. And we get the answer of 23.42. So that is the conclusion of our addition and subtraction of decimals. The next session we'll be looking at multiplication and then division, and we've got some great, fantastic techniques actually for doing multiplication and division of decimals. So very much look forward to going through those with you. Thank you.